Yesterday we got the news that we lost Stephen Hawking, certainly the most remarkable physicist of our age. I somewhat knew him, we shared many friends in common. He was like a hero to me. We're certainly saddened by the passing of Stephen Hawking. He was a great man, a man of science, but I'm glad that he was able to live a long and full life. More than 50 years longer than predicted by those who diagnosed him with ALS, when he was at his early 20s, yet made this far. He achieved so much. Against the laws, it's fantastic to witness that. He was brilliant, of course. He was a man of immense personal courage, and as a scientist, he has worked on the hardest, most significant, most fundamental questions of science, and he wrote in a wonderfully elusive way. Even he was writing about most abstract ideas of mathematics. I admire all of that. But the thing that I will treasure the most about him was sense of fun. He took such obvious delight in life. And in this business of uncovering the secrets of the nature, his most characteristic expression was a sort of grin. And it was infectious. We're learning wonderful things about the universe. That's what I love about him. Stephen Hawking was a physicist who made enormous contribution in our understanding of the black holes and in other topics ranging from physics to cosmology. But I think his effect on us is actually more profound. Think about it, talking with a guy who because of a disease had severe limitations, who was severely confined, and yet his mind went over the universe contemplating things great and small. I think that Hawking's very existence reminded us about how profound we all are. We're confined by the levels on our intellect. We're confined by all the locations on Earth. And we're confined the brief span of our lives. And yet some way like Hawking we need to be brave enough. He was certainly an inspiration to me. I mean, he could do all the stuff largely all in his head. Confined to a wheelchair. Then certainly the rest of us should do what we love to do. I mean, he could have easily given up. He could have said enough. Just forget it. The world has given me bad, hand, and I'm not gonna do anything about it. But there he was, completely confined to his wheelchair, even not able to sleep for a few decades, and yet he did all the calculations in his head and conveyed them through a machine. What an inspiration! I got to meet with Stephen Hawking many times. In fact, when I was a graduate student in my PhD, he called me in his office to offer me a job as a postdoctoral position over in Cambridge. Unfortunately, I had to turn him down for various reasons, and I ended up going to MIT. 3 years later, it was time to get a new job. I applied to Cambridge again. Hawking offered me another job. I had to turn him down again, and ended up going to UC Santa Barbara, the Institute for Theoretical Physicists there. And it was at UC Santa Barbara when I finally met Hawking and talked to him face to face for the first time. We were all walking to lunch. Hawking used to visit California almost every year, and he would drop by both Caltech and Santa Barbara. So one day in Santa Barbara we were walking to lunch, and I was standing next to Ruffalo Russo, one of Hawking's graduate students, and I said, "Raphael, you should introduce to me to Stephen. I've never actually met him before. But as a joke, I hope he's not mad at me. He offered me a job and I turned him down." And Raphael says, "Don't worry about that. There's one guy who turned him down twice." So I had to explain him, "Yeah, that was me." And Raphael ran towards Stephen Hawking saying, Stephen, this is the guy who turned you down twice." As it happens, I'm about to get on a train to go give a theoretical physics talk at Cambridge University, where Hawking made his home. And I'm sure I and my colleagues will swap Hawking stories over the dinners. I saw him enjoying some flamingo dancer on the stage in his motorized wheelchair. There was a lot of laughter and deep appreciation of what he did and left for us. Hawking will be sorely missed, not only for his research. He was profound and influential, and also perseverability to aspire and to communicate science to people old and young alike. His life was well lived, and we will miss him. Let your legacy and inspiration live on. We are just an advanced. I first learned about Stephen Hawking when I was an undergraduate physics student, when my professor gave me a copy of The Brief History of Time, and I just adored it. I just loved everything about it. At that point in my education, I'd only learned about some pretty mundane parts of physics. I learned about objects slide down from inclined planes, and learned a little about electricity and magnetism and motion and things like this, but that doesn't capture the wonder of modern physics. And what I mean by modern physics is that encapsulated by Hawking's work. Of course, he'd written his work in a popular book, A Brief History of Time, and is pretty rough in the chapter 3 or 4. In fact, I'd like to say, it's just the most complete book of all time. And people buy it, they put on their hobby tables. And when people see, they say, "You're reading Stephen Hawking, you must be pretty smart." Well, I don't know how many people really understand that book, pretty rough going. Nevertheless, its millions of copies have been bought. This interesting issues of black holes and general relativity and quantum physics to the public. This is an amazing book. If you haven't read it, by all means, seek it out. It is poetic and captures the wonder and amazement of general relativity and quantum mechanics in a way that very few books have ever done. You'll not regret it. So I think that Hawking's book, A Brief History of Time, struck a nerve, struck a resonance in all of us, because it reminded us of what humanity has been possible to learn despite all of our limitations. I think his book stands as a symbol of power of the human mind to transcend the boundary of our lives. My first scientific work was on black hole thermodynamics, a field that he invented with his discovery of the quantum radiation emitted by black holes. That was probably the most significant of his accomplishments, but there were many more. I have a special love of his early work with Roger Penrose on Einstein's general relativity. The so-called singularity theory would truly revolutionize the way we think about the formation of black holes and the Big Bang. In particular, he showed that the information inside the black hole is not proportionate to the volume of the black hole like everyone would have expected, but to the surface area of that black hole. Probably his greatest legacy will be the prediction that black holes evaporate through the quantum process, like particles flipping away gradually with time. It takes very long time for black holes to fully evaporate. Right now, right this very moment, my research career is focused on perhaps Hawking's greatest legacy, the black hole information loss paradox. You take a black hole and you throw some information, like a book or something like that, and Hawking showed that the black eventually evaporates. So what happens to the information that was contained in the book? By the laws of physics, we understand that it should go somewhere, but naively Hawking's calculations says it doesn't go anywhere at all. It just gets destroyed. So decades later, after he posited his puzzle, when it was back in 1970, we still don't know what the answer is. We're still struggling to figure this out. And this is the first step in the unification of quantum physics. The physics that is very small and general relativity in physics that is very large. Theoretical physicists have been after such a theory for decades, and we still don't have something that is complete and unique. It's generally defined that black hole evaporation is a feature, a consequence of any successful quantum theory of gravity. And so Hawking did those first baby steps into a unified theory. This plays a huge role in our understanding of quantum gravity, and although we don't really understand quantum gravity yet, whatever the answers are to the questions that quantum gravity is trying to address, Hawking's work certainly play a major role. It's hard to overstate how Hawking's contribution were in this respect. My mind is puzzled with Stephen Hawking's greatest gift to physics. That's what physicists love. Some question is easy to ask. It's very, very hard to answer. And we are all hopeful that thinking about this as carefully as we can will help to reconcile quantum mechanics with gravity. And then so I think Stephen Hawking will be very proud to know that the role he played in doing that. If you want more such videos, then subscribe.